All right, gang, welcome back. We're on to another lesson. This lesson is going to be piecewise functions, and we're going to learn how to graph them and state characteristics of them. So what is a piecewise function? It's a function that is defined by at least two different equations, and it's going to have two different sections of the domain being used, one for each part, or more depending on how many sections you have. So here's our first example. We're going to graph f of x equals 2x, where x is greater than or equal to 1. And then we're going to graph negative x minus 4, where x is less than 1. So these pieces right up here are the areas where the domain is being split. Okay, so I kind of like to give myself a little bit of a visual, and at x equaling 1, I just kind of put a little mark there. Hey, on one side of the graph, so where the x's are greater than 1, I'm going to graph y equals 2x. That's the function I'm going to graph on that side because it says greater than or equal to. The equal to underneath means that we're going to have a closed circle at x equaling 1. Okay, so keep that in mind as we go through. And then the other part of the function, I'm going to graph negative x minus 4 when the x's are less than 1. So the negative x minus 4 is graphed on the left-hand side. Okay, that one has a less than symbol, so that's going to be an open circle at x equaling 1. We'll get domain, range, intervals of increase and decrease, and all the other info as we go through. So let's go ahead and start with graphing y equals 2x. I'm going to make myself a little chart over here, x and 2x. I want to start at x equaling 1 and go a few points bigger. So if x is 1, my y value is 2, and then 4, 6, and 8. So at x equaling 1, I have to start at the point 1, 2 with a closed circle, and then I'm at the point 2, 4, 3, 6, and so forth. So I'm going to continue that graph with an arrow leading up. There you go. That's the left-hand side. Now on the right-hand side of my graph, I have another line. The y value is a negative x minus 4. So again, I'm going to use 1 because I'm starting at that value, and then I'm going to work backwards. So we'll go 1, 0, negative 1, and negative 2. When x is 1, that will give me a y value of negative 1 minus 4, so negative 5. When x is 0, I'll be at negative 4. When x is negative 1, that would give me negative 3, and then just follow that pattern. So when x equals 1, for the second part of the function, the y value is negative 5. And I need to have an open circle at that particular point. Then I'm at 0, negative 4, 1, negative 3, negative 2, and so forth. Continue that function following its pattern using its slope. There you go. Okay, so our domain, cool, that's all the x's. But remember, we do have a break in the domain. I've got an open circle and I have a closed circle. That is going to be our value where our point of discontinuity occurs. Okay, so the domain does go from negative infinity to 1 with a parentheses, and then union a bracket at 1 to positive infinity. Alrighty, the range, these are all of your y values. So the lowest y value that our graph has is down here at the point 1, negative 5. So I'm going to start at negative 5. It's not included because it's an open circle, so that gets a parentheses. The red section and the blue section will then both continue up to positive infinity for your range. Okay, when we're looking at intervals of increase and decrease, we are looking across the domain for both of these. So we're going to split up the domain and see which section is decreasing and which section is increasing. So traveling from left to right, the red section of my graph is decreasing. So that's going to go from negative infinity to this x value. Where does our graph change direction? At 1. Cool. And then it picks up, it jumps to another portion, and then again, starting at +1, going out to positive infinity, the graph is then increasing. So that domain does have one section that decreases and one that increases. Where's our point of discontinuity? Where does that change? Okay, that is definitely occurring at x equaling 1. We saw that from the very beginning. And if you want to look at the point that's discontinuous, it's specifically the point 1, -5. And that's again where we have that open circle in the graph. It's not included. Okay, so our end behavior, we're looking on the far left and the far right sides of the graph. So as x approaches -infinity to the left, those y values, f of x is approaching positive infinity, it's going up. And then as x approaches positive infinity to the right, f of x, those y values are also going up to positive infinity. Good job, that's our first one. We're 6 minutes in. It takes a little while to do these, so just stick with me. All right, here we go. Number 2, f of x is x squared, where x is greater than or equal to -2, and x minus 4, where x is less than -2. So at x equaling -2, that is the split of my graph. That's where my function is going to be discontinuous. I'm going to graph the x squared function to the right. So let's go ahead and get some points there at -2, -1, 0, 1. When I put those values in and square them, the corresponding y values are 4, 1, 0, and 1. If I picked +2, then I would end at a +4. All right, so again, checking this one out, our first function, x squared, where x is greater than or equal to -2, does have a closed circle. So my first point at -2, +4 has to be a closed circle. I'll then have the point -1, 1, 0, 0, 1, 1, 2, 4, and so forth. Now remember, I'm only starting at the point -2, 4 on the left part of the graph, but the right side continues up to positive infinity. The second section of our graph is a linear function where our x values need to start at -2 but go smaller, so -2, -3, -4. The corresponding y values will then be -6, -7, and -8. I do have an open circle for that very first point at -2, -6. Then I have regular points at -3, -7, -4. Oops, I went the wrong way. Excuse me, gang. Oops, let's erase those. There we go. So these other points are going to land off the graph, and that's totally fine. We're just getting a rough idea of what happens here. Okay, there we go. There's our graphed function. So let's talk about our domain. Let's look at all those x's. So all of the x's are included, except we do have that point of discontinuity at x equaling -2. So I'm going to state -infinity to -2 with a parentheses, union, a bracket, -2 to positive infinity. The range is going to be all the y values. So if you look at this section of our graph, this bottom piece is increasing up to that y value, this particular point at -2, -6. So we're going to go ahead and state that the range starts at -infinity and travels to -6, parentheses. It's got a big, huge empty section in the middle. All of this stuff right here is empty. It is not included in the range. So we're going to pick our range back up, starting at this y value, the vertex of that quadratic function at 0, 0. So our range is then going to continue on, union, bracket from 0 up to positive infinity. Good job. All right, what sections of the function increase and decrease? Where's our point of discontinuity? So as we're looking at our increase and decrease, the red section that I have graphed, x minus 4, that is increasing. So we will travel from negative infinity to negative 2. Remember, these values go across the domain, so look at the x's. Okay. Then when I get to negative 2, my function changes and does something different. That's the blue section. Between negative 2 and 0, the function is decreasing, and then it picks back up at 0 and increases again. So the intervals of increase are negative infinity to negative 2, union 0 to infinity. The decrease is negative 2 to 0. Our point of discontinuity, we already have that labeled. That is at x equaling negative 2, and the ordered pair is negative 2, negative 6. That is the whole. That's a removable discontinuity. And checking our end behavior, same phrase every time. As x approaches negative infinity to the left, the y values f of x is decreasing to negative infinity. And on the right, as x approaches positive infinity, f of x, those y values are increasing to positive infinity. Okay, good job. Number 3, f of x is negative x minus 3, where x is less than or equal to 0, and x squared minus 4, where x is greater than 0. Okay, so the first one in this case is our less than symbol, and it is a closed circle. So at 0, that's where we have that break in our graph. Yay, the y-axis. We're going to graph negative x minus 3 on the left-hand side. Let's go ahead and get some points. So we'll start at 0 and go backwards. 0, negative 1, negative 2 gives us corresponding values of 0, negative 3, negative 1, negative 4, negative 2, negative 5. Again, I do need a closed circle at 0, negative 3. And, oh, I think I did those wrong. I sure did. Whoopsies. Silliness. Those y values. 0, negative 3, 0, negative 1, negative 2, and negative 2, negative 1. Oopsies. There we go. There is the line segment for that one. It's ray, that section of it. Alrighty. Our next graph is x squared minus 4, where x is greater than or equal to 0. So I'm going to start at 0 and increase. Substitute a 0 and I'll get negative 4. A 1 will give me negative 3. A 2 would give me 0, and 3 squared is 9 minus 4 is 5. I do need to have an open circle for the right-hand side of my graph for the x squared minus 4. So at that y-intercept, 0, negative 4, open circle, 1, negative 3, 2, 0, and then 3, 5. And there's a portion of that quadratic function that we have graphed. Good job. Okay, our domain. Remember, we're looking at all of the x values. So our domain is from negative infinity to 0, with a bracket coming from the left, union 0 with parentheses going towards the right, towards infinity. The range is your y values. The lowest y value occurs at where the vertex is of that quadratic portion of the function, and that is at negative 4. So we're going to start at negative 4 with parentheses, and we are going to increase up to infinity. That's parentheses because it's an open circle. Remember, checking domain for intervals of increase and decrease. So the red section, negative x minus 3, is decreasing. Okay, so we will travel from negative infinity to 0, where it decreases. And then at 0, that's when we start our next portion of our function, our piecewise function, and we increase 0 to infinity. Our point of discontinuity is that lowest point that we have. It occurs at x equaling 0, and it's the ordered pair 0, negative 4. And last but not least, end behavior. What does the left side of your graph do? And what does the right side of the graph do? As x approaches negative infinity, f of x, those y values are increasing to positive infinity. And as x approaches positive infinity to the right, again, those y values are increasing to positive infinity. Okay, great job. We've got a chunk of these done. We're at the 15-minute mark, so I'm going to pause here and come back with the remainder of the problems in another video. Good job, guys.